This video is to show you how to do problem number 3 of energy conservation with rotation word problems. So now I want to find the rotational kinetic energy. So my rotational kinetic energy is this formula right here. It's 1/2 I omega squared. Now look, that looks just like my kinetic energy. My linear kinetic energy right here is 1/2. They're both 1/2. And again, when you're spinning, your I has the same effect as M does linear. So my kinetic energy depends on M. My rotational kinetic energy depends on I. And I have velocity squared for linear. I have angular velocity squared for rotational. So I have KE rotational equals 1/2 I omega squared. So I need these two values. I have a hoop and I have a radius, so I'm going to have to find my I. And my I for a hoop is just mr squared. So my I equals mr squared equals my mass is 15. My radius is 1.7. And that turns out to be 7.6. I'm sorry. That turns out to be 43.4. And again, that'd be kilogram meters squared. So I need my omega. I have a linear velocity, so I'm going to go to this formula right here. They give me linear, so I can find omega. So my linear velocity equals my r times my omega. So my linear is 5. My r is 1.7 times omega. So when you solve for that, your angular velocity turns out to be 2.9 radians per second. So now I can just plug in here that this is 1/2. My I, which we said over here was 43.4, times my omega squared, which is 2.9 squared, which turns out to be 182.5 joules. That's how you do problem number 3.